So hello everybody. Start timer. Hello everybody. I'm Nick Dipatri and I'm an engineer from the Comcast Corporation. I really appreciate you staying for this session of DroidCon New York 2025. Thanks for being here, folks. I appreciate it. So today we're going to learn about Compose Multiplatform, Rive animation, and my espresso machine. So I call it RoboGaja. It's a robotic espresso machine that I built. It uses Compose Multiplatform to render the user interface. In fact, here you see an iPhone running this app. So a friend of mine drew me this cool coffee robot image. Here you can see I'm using it for my wake screen in my application. So I thought it would be cool if I could animate this robot. If I could actually show the robot walking and somehow use that animation within my application. Now, I already have this fire animation here. If you're looking, can you see that? So this took a lot of coding, right? This is a Doom fire, if you're not familiar. It's the fire that lights up when the boiler's going to heat up my coffee. It involves composables, canvas rectangles, draw scope, launched effect. So I wanted an easier alternative to creating engaging animations in Compose. So that's when a coworker of mine introduced me to a design and animation tool called Rive. It's used by Duolingo, by the way. So Rive's amazing. Rive allows artists to create beautiful animations using a visual development environment without any coding. So the output of this development process is a binary artifact that runs in a Rive runtime engine. These runtimes are available on many platforms, including Android and iOS. So I thought, great, I want to use Rive to animate my coffee robot. So where do I begin? So my Compose Multiplatform application, RoboGaja, uses composables exclusively to render its UI. How do I embed a Rive animation as a composable while behind the scenes rendering it using either Android or iOS rendering engine in Rive, right? So how are we going to do it? Let's find out together, folks. As promised, this is going to be a live coding presentation, and today we have Wi-Fi, so this is going to be great. So at first, we'll be jumping back and forth between Android Studio and Xcode. Then we're going to dive into the Rive IDE to actually create a robot animation. So it's like a 2-for-1 in this talk, and so we're going to do this the next 30 minutes. So we're going to start from scratch using JetBrains Online KMP Project Wizard, right here. If you haven't used this, so you select our two platforms, Android and iOS. And now you have to make sure you select Share UI, because that makes it a Compose multi-platform application. Then we go down to the bottom, we click Download. Now I open up this zip file in Android Studio. I made it white. I usually do dark mode, but I made it white so you guys can see it. Can everybody see it okay? Great, excellent. Okay. So if we open this up, this is a Compose multi-platform app. If we open this up and we go into Common Main, we see our main app composable here. This runs on both Android and iOS. How do we replace this how do we replace this composable with the Rive animation composable? So for those of you who are familiar with KMP, multi-platform, you can probably guess that our solution begins with KMP's expect actual mechanism. If you aren't familiar with KMP's expect actual mechanism, let me go through it right now real quick. So with KMP, you have a common main, part of your source code, right, which contains our pure Kotlin code. This code is not platform specific and it runs on both platforms. You want as much of your KMP code as possible to reside in here. So if you use the expect modifier on a function inside of your common main module, KMP will require you to then provide an actual implementation for all declared platforms in your project. So for example, we're going to go into app, but we're going to go into greetings, and then we're going to get platform. And here, we're still inside a common main, but see, it's got the expect modifier. So the actual implementation for get platform resides in both iOS main and Android main modules. Right? These modules contain Kotlin code, but it's platform-specific Kotlin code, or rather it can be. So for an example, I'm going to go into here, And we're going to look at the iOS implementation, right, which is inside of iOS main. Okay, if we look at this, we can see that we have iOS implementation inside of iOS main. For an example, we have UI device. This is part of iOS's UIKit API. In fact, if I click into this, you're going to see it's an Objective-C class. Everybody see that? So the iOS main module can only contain Kotlin that's been compiled from Objective-C. In general, you can't use Swift classes directly inside of this module. Okay, back to the problem at hand. Let's go back to our main app, and we're going to replace this huge composable here with our Rive animation. We're going to do that now. So, okay, so we're going to call this Rive animation. See if my fingers work here. And then I'm going to use live templates, folks. That's going to help us with our coding today. All right? So now the IDE is complaining because we haven't provided our actual implementations for this composable function that I've created here, right? That's because we're using the expect. So let's start by implementing this. We're going to start with Android, okay? I've already pulled in the Rive runtime dependency, right? If you look at our main Compose app and go into the build file, you can see I pulled in the Rive dependency under Android dependencies, okay? So that's there. So now also with Rive on Android, you have to initialize the Rive runtime engine. So we're going to go into the Android code, which is in here, Android main. We're going to open up the main activity, and we're just going to pop this down here in the main activity, Rive init this. Okay? Okay, so now we can go back to our common main app file and build our actual Android Rive implementation. So remember, we're going back to common main in here, and now we're inside here, and now we're going to implement this. So we're going to click option, turn, add missing declaration. This just makes the file for us. The IDE is helping us here. Android main, boom. Now this is inside of the Android main module, right? So this is Android specific code. All right? So now we need to insert our own Android implementation of this Rive composable. Now in Android, it's fairly straightforward, right? I said fairly. Okay. And we were missing a conclude, so I'm just going to do this. Boom. Okay. So notice we're inside of Android main module again, right? And our composable is a little complicated because we have to use the view-based Rive animation view. I think Rive has a composable now, but I haven't gotten it. Maybe. It was supposed to come out this month. Okay. So important thing to get out of this code snippet is that Rive animation view is what utilizes the Rive animation, it utilizes the Rive animation engine, okay? So now notice we have this coffee robot. This is our actual artifact that we're going to create a little later in Rive, okay? So going back to our main app, we can see it's still red, and that's because we haven't provided our actual iOS implementation. Let's do that now. Okay, so we're going to do add missing declaration, iOS main, and this one is in, you guessed it, iOS main. Okay, so we're going to include this. Okay. So remember, we're inside of iOS main now. So we need to render our composable, but the Rive animation is in iOS, the Rive animation is a Swift UI component. That's the rub. Okay, remember we can only use code that's been cross-compiled from Objective-C to Kotlin. How do we do this? Well, the challenge here, right? How do we embed or wrap our Swift UI element into a composable defined in iOS main? How do we do this? So for this, we're going to use Compose Multiplatform's View Interop tools. So let's go ahead and use that now. So right here, we're going to do Rive, okay? Okay, so, and we're going to wait for the imports. My auto imports aren't great, so I have a little backups here. Okay, so cool. So we have this thing called UIKit View Controller. This is from the View Interop SDK. It emits a composable, right? That's good. That's good, right? Right, because that's what you need here. And it also takes in a UI View Controller as an argument. UI View Controller is from iOS's UIKit SDK. UIKit is how iOS did UI before Swift UI. but it's still supported. In fact, that is what makes Compose Multiplatform actually work. More importantly, UI View Controller is Objective-C based, and that's why we can see it used here inside of iOS main, and it's why this thing compiles. So we're getting somewhere. So now we just have to figure out how to convert Rive's Swift UI component to a UI View Controller, right? We're just kind of stepping along here. Okay, next problem. The Rive Swift UI component, it's a Swift class, right? The only place we can put a Swift class is inside of our actual iOS application. Okay, so we haven't talked about that yet. Let me open this up a little bit here. We haven't talked about that yet. Let's open this up. Remember, this is our main KMP project, and down here we have this. So the way we start our Compose Multiplatform app on iOS is by wrapping it inside of a small iOS application. That's what this is right here, okay? That's where we need to go now to convert our Rive Swift UI component into a UI View Controller. Everybody got that? Okay, so we're gonna open up this iOS app in Xcode. Remember, I promised you we're gonna go back and forth. Now we're gonna start jumping into Xcode. It's the easiest place to write Swift. So let's go over to there. Okay, so I've not written anything yet. This is vanilla this is right out of that project we downloaded from KMP, Project Wizard. So this is a vanilla iOS app. We're starting from scratch, folks. So let's create a new class where we can convert this Swift UI component. We're gonna say new empty file, native UI View Controller Provider, okay? Native UI View Controller, okay. So now we have live templates here as well, thankfully, okay? Now, at a high level, we can see that this is a factory method, right? And it instantiates Rive's Swift UI component. It's called Rive View Model, but trust me, it's a Swift UI component. And it converts it into a UI View Controller. That's exactly what we want, okay? And it's also, as you can see, it's also expecting our Rive artifact that we're gonna build a little later. The rest of this is Swift UI code. We're not gonna worry about that. But we do need to pull in the Rive runtime for iOS. Remember, because this is a small, remember what we're doing here, folks. We're using Compose Multiplatform, we're running it on an iOS app, but that iOS app has to have the Rive runtime environment, so we need to install that. So on Xcode, we call the Swift Package Manager. Now, I wasn't sure I was gonna have network connectivity. Network connectivity is required for this, so I've already attached it here. I'll do it again. So you can see, all you have to do is type in URL, and it finds a Rive iOS dependency, and then we attach it here. And now it shows up down here, okay? So now we have Rive installed on iOS. Okay. So we have our Rive Swift UI component embedded in a UI View Controller, right? Unfortunately, it's inside of our iOS app, not in our Compose project. The question is, how do we pass this from iOS to our Compose app? So let's go back to our Compose app and look again where we need this UI View Controller. Okay, we're back in our Compose app, right? Remember, we're inside of iOS main now, right? And we're looking at our composable. And this is where we need that UI View Controller, okay? Everybody with me? You good? Everybody good? All right. So it's helpful to think of iOS main as a library module and the iOS app as a feature module. And Thaddeus might freak out hearing me say that, but it helps me to think of it that way. Okay, at compile time, the iOS app can see code compiled from the iOS main module, but not the other way around, right? So the iOS app the iOS main module can't see iOS app, right? And this is a classic one-way dependency relationship that we already know about in our Android apps. So let's work with this, folks. So let's define a UI View Controller provider right here in iOS main. Okay, so we're gonna do that here. And then I need to do one import, my finicky import. Okay, so what do we have going on here? So let's use this provider interface right here. We're going to use this provider to retrieve our UI View Controller. So we're going to go up here and grab that UI View Controller. Val factory equals local view, blah, 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 blah. I'll explain that in a second. And then we're going to go down here. We're going to use that factory to create our UI View Controller, okay, using this interface. Now, where's this interface coming from? So the good news is, hey, this compiles. That's good. Okay, you can think of our new interface as a form of dependency inversion. We're declaring our need for this UI view controller provider, okay? We're using composition local down here to inject this provider. Now, if you aren't familiar with composition local, it's essentially a static variable, okay? This is not the optimal way to do injection, but it works for demonstration purposes. So now let's go back to our iOS app and change our new class so that it implements this interface. Okay, ready? We're going to go back to Xcode. So now we're in, oh, I forgot something, folks. We just wrote new code in iOS main. Remember, it's like a library module. So we need to build this code and convert it to Objective-C. Well, guess what? Thaddeus and the folks at Touch Labs and JetBrains, they've done all this work for us. We just go up here and click sync. When you do sync, this engages a KMP plugin, the task, at Gradle task, and it actually builds the Objective-C code for us. Okay, so now the code's been created. Oh, wrong way. Now we're going to go to our Xcode, and so remember, we're going back to Xcode now, right, to inject, to implement this provider, right? So we just declared the provider, the interface in Android. Now we're back in Xcode, and we're going to use that interface. We're going to implement that interface here. But now here's the thing. We have to use that Objective-C code. Now, if this was Android, we would click sync, right? Gradle sync to get more code in. But this is Xcode. It doesn't have a sync. You just build again. And that's going to pull in that new code, that new interface that we just defined. So now that I've done that, right, it's building up here. This is where I talk for a second. So it builds. Let me drink of water. Okay. So now we can go up here and we can say this implements UI view controller provider. There you go. See it? There it is. That's an Objective-C class that we just wrote. So now this implements the interface that we have, that we've defined in our child library module, which is what I'm calling Compose, our Compose app, a library module, just for the sake of, that's where we're getting this interface from. So here's the cool part. We can actually pass an instance of this provider to our Compose application at runtime. Okay, so let's look at this content view Swift class. The content view Swift class is where our thin wrapper iOS application passes control over to our main Compose application, right here, okay? The main view controller function actually resides inside of iOS main. So this is where we can pass in our view controller, UI view controller provider. So now let's go to where we define this main view controller function in iOS main in our Compose app. So I'm going to go back to Android now, folks. I know we're going back and forth a lot. So remember, now we're talking about iOS main, and in here, main view controller. This is where control passes from iOS into our Compose app. So we're going to rewrite this to take in a provider as an argument, okay? So we're going to delete this. Okay. Let's see if our IDE picks up the imports. Nope, okay. Okay, there you go. So notice we're also defining our provider as a static property. This is how we're going to do the injection. It's a static variable now, right? But here, look, we're passing in that provider into our main view controller. So now we can return to our iOS app and have it pass in our new provider using this new function argument we just created. But remember, we have to sync first, right? We have to build this new Objective-C code we just wrote. So you guys are going to be iOS developers before you know it. Okay, that wasn't even funny, sorry. Okay, so now we're back in iOS and we're going to run build. Okay? And now remember, why do we do that? Remember, we're modifying this function to take that new provider as an argument. So near, oh, look what's happening. I'm missing an argument. Isn't that great? Okay. So now we're going to pass in an instance of this provider. So we're going to do UI view controller provider, NS, nope, native view controller provider, boom. Okay, there you go. We're passing in an instance. Now here's the weird thing about Swift. When you're passing in an argument, it uses a colon instead of an equals. That messes up my brain immensely. So we're passing in an argument right here. We're saying, for you Kotlin folks, UI view control provider equals a new instance of this. Okay, you got that? It's weird, yeah. That's what freaks me out. It's so simple. I don't know why I can't get it. So guess what, folks? We're done with Android and iOS code. It all works. It all compiles. What's next? So remember I said this is like two talks for the price of one. Now what we're doing is we have to now provide this coffee robot artifact both for iOS, right, and in Android. Remember on Android, it's right here, right? We have to provide this coffee robot. Ooh, good thing I saw that little build error there. So we have to provide this artifact now. And we build this artifact in Rive. So here's a really fun part, folks. We're going to step outside of our comfort zone. If you weren't already outside your comfort zone looking at iOS, we're going to step out even further and use Rive, a third IDE in this talk. So how do we make our coffee robot walk? So learning how to animate characters in Rive. Okay, let me close that. So learning how to animate characters in Rive isn't so hard thanks to Rive's amazing YouTube content. So let me go over to that, right here. So here is Rive 101 YouTube channel, which is all I had to consume in order to animate my robot. So let's make our robot run by going to our Rive IDE now. So we're going to go over here, we're going to go over our two other IDEs and go to our third IDE of the day. So it's actually, it's a thin wrapper around a web app. So thank the Lord, Allah, Yahweh, that we have Wi-Fi. Okay. So this is going to be a quick introduction to Rive. My hope is to pique your curiosity, so you will try it out for yourselves and see how awesome it is. Okay. But it's going to be quick. Okay. So here is our artboard. I've chopped up that coffee robot image, right, into a bunch of small images. So here you can see I have a bunch of images that make up the leg. And here's these segments, right? This is my the whole coffee robot, and this is my leg segment right here, okay? Everybody with me? And here's my foot. Woohoo! Okay, so how do we animate this leg? Well, how in the world do you do that? Well, in the animation world, we call this rigging. Okay, and Rive uses bones to attach these bones to these pieces. So it actually worked out perfectly because these are bones that I want to attach to my robot. So what we're going to do is going to create a bone chain. So we're going to zoom in here, and we're going to attach these bones like this. We're going to walk down 8, 9. Okay, so I have 9 bones that I've attached to this. So here's my bone group. I'm going to pull it down inside of our leg group. Okay, I'm going to rename that to bone 0. Let's open up our bone chain, as they call it. And there should be 9 bones. Okay, there you go. Now let's look, for example, at bone 3 and rotate it. Whoop. Okay, now the problem here is it's not attached to the images. How do we bind our bones to the images? Well, we simply just drop them on top. So the foot bone is going to go on the bottom bone here. And then we're going to march our way. You see now it's like a child of that, right? So now we're going to march up and drop these on all these. So bone 7, bone 6, bone 5. And what I'm doing here, folks, again, remember, is I'm creating a bone chain that makes up the left leg. And yes, I'm just randomly talking until I actually finish this rather tedious task. Hope I don't mess it up. Okay, I think I got it. Okay, good. So now we've done that. Now let's look at bone 3 and move it. Woohoo! How cool is that? Cha-cha-cha. Okay, now that's not running, folks. Okay, that's just me being silly. What we really need to do is have all these bones kind of move. Now, in robotics, we call this forward kinematics. When you go and literally explicitly change all these bones and rotate every one of them a certain degree, different degrees for each one to affect a change in our target, which is our foot. Right? We want our foot to go up here. That's what we want to do when we run. We want our foot to go up here, and that would be forward kinematics. It'd be really hard. We're not going to do that. Rive actually supports a thing called inverse kinematics. Inverse kinematics is where you say, hey, Rive, I want to take my target, this foot, and I want to move it up here. And I want Rive to figure out how to change every one of those bones in the bone chain, different degrees, different amounts, in order to affect that target, to move that target where I want. That's inverse kinematics, and we're going to do that now. It's very cool, very exciting. So first thing we need to do is create a target for this foot. So the foot is a target, but we need to create an actual target object first. So I'm going to hit the G key in Rive. I haven't done anything yet in Rive. You've seen everything I've done. No magic hand movements here, but I'm hitting the G key and clicking right here. Boop. That creates a new group. So this group is out here. I'm going to put it inside the leg, and I'm going to call this group IK target. This is my target for my inverse kinematics that we're going to do. Okay, it's right here. Now I want to attach this target to my foot, really my leg bone, right? Because remember, the bones are what we're trying to control. So we're going to go into this bone, and we're going to add a constraint to the bone called IK constraint, and we're going to define the target right here to be the target. IK target. Okay, so there you can see it moved. So now the bottom bone is tracking the target, which is the foot, okay? But it's only one bone. We're going to increase the bone count, and all the bones are now following that target. I just increased the bone count up from 1 to 11. That's all I did. So now, watch what happens when I move the target. Cha-cha-cha, cha-cha-cha. Okay, we have something that's starting to look like a leg that's running. All right? Sorry, I know I'm zoomed in here, but I think it's probably the best way to do it. So again, if I grab this target and I create a path here with my trackpad, this looks like he's running. But I'm not going to stand here all day while the world watches their animating robot. So we need to automate this process. How do we create a path, elliptical path, as you can see, for this target? Well, we're going to draw an ellipse. We're going to start with that. So I want to go over to ellipse. I'm going to put an ellipse right here, okay? Now let's see if that ellipse will work for us. Good enough. All right, that ellipse works for me. This ellipse is going to be our path. Now, the question is, how do we create an elliptical path? How do we constrain our target, this, right? How do we constrain this target to follow an elliptical path? Can you guess? You go to constraints. So you make sure you're selected the target. You go to constraints, and lo and behold, we see follow path. Ooh, isn't that great? So we're going to click on that, and our path is going to be the ellipse. Boop. Now you can see the target is locked into the path. Now we're going to hide the path. Where's the path? Oh, you know what? The path's up here. We're going to pull this down into the leg group. Now it's always important to use these groups. They help you. For example, right now I can disappear the whole leg. You see that? So the groups are important. So let's make this ellipse invisible. We're going to go over to here, and we're going to hit the wrong button. There you go. Now we're going to do the alpha channel. Now the ellipse has disappeared, but it's still there, folks. Lurking, being our path. So remember, we're going to look at our target. We're going to look at its path constraint, and here is our path. Now, here's what's the most interesting part. We now have one attribute called distance. If we increment that, what I'm doing here now is I'm just sliding my mouse up, and that, theoretically, and that increases this value. See what I'm doing? All I'm doing is I'm increasing the distance value. This is the distance along that path that the target is traveling. Guess what I've just done, folks? I have created a single attribute that if we animate, if any of you have done animations, you know it's just about making attributes increment or decrement automatically. That's all I'm doing here. To animate this, all I need to do is increment or decrement this distance value. Like that, okay? Great. So let's do that. Let's animate that value. Well, how do you animate in Rive? That's what we're trying to do here, folks. You click on the Animate tab. Now we need to tell it what to animate. So again, we're going to go to the target. We're going to go to the path constraint. And we're going to click on this diamond next to the distance attribute. That's how you animate things. And now it shows up in our animation tab. All right, so let me show you this. I kind of jumped around here. So this is the animation panel. This is a playhead. If you've ever done video editing, this is a playhead. We're going from 0 to 1 seconds, okay? At 0 seconds, we want our path to be 0, okay? Let's delete that set point. Now at 1 second, at the end of our loop, we want the path. We want our target to be 100% along that path. So it's actually going to go full loop, okay? So 100, tab. Now watch what happens. Now I have it in cycle mode, and I want to press play. Now we have a running leg. Let's give me a hand. All right. Now, I think there are many people in the world that can function with one leg, and I think they're awesome. But we're going to make our robot, we're playing God here. We're going to create another leg for our robot. Let's do that real quick. Okay, so we're going to go back to design. Now remember what I talked about, it's really nice to have groups. Because watch this, Control-C, Control-V. We now have a right leg, okay? Let's make our left leg invisible. And here is our right leg. It's in the wrong spot. It's parked on top of the other leg. So we're gonna move this over, maybe. We're gonna move it up a little bit. Now here's the weird thing. Now you can see that the robot body's kind of rotated, so the right leg is in front and it should be behind. So in Rive, this panel here is the Z order of all of our elements. So if I bring this down and drop it behind that, boop, it goes behind the body, okay? So that's good. So now we can let our left leg appear again. Now, we want to now animate the right leg as well. So let's go back to the animation panel, and now we're going to go in. We're going to open up our right leg, and we're going to go into IK target. And remember, we're modifying the distance of the target along the path. So we go to the path constraint, and we click on this value. This is how you add things to the animation panel. Click. So now the right leg is animated, is in here. So now we don't want him to jump rope. We want him to run. So we're going to offset the legs. So when the left leg is at 0, we want this to be at -60. Can anybody guess what number we want to use all the way at 1 second? If it's -60 and we want to go to 100, what is it going to be here, folks? 40, right? -60 plus 40 is, wait, what is that? Oh, forget, whatever. It's -20. Forget it. The math isn't important here, folks. You get what I'm trying to say. All right, so let's zoom out and let's press play. Boom. We have a running robot. Okay, thank you. Oh, but wait, there's more. But wait, there's more. Okay, so I've actually gone ahead and done a little more animating here. I'm going to select a different art panel here. Let me make sure I got the right one. Okay, so now if we animate this one, how do we do that? Boom. I click on this, and there you go. Now look, this guy's doing a little more than before. Okay, so we have a running robot. I'll zoom in a second and show you this, but I want to get this thing exported to both of our iOS and Android, because remember, we're trying to develop an application here. So we're going to export this. We're going to export, remember, we're exporting the artifact that they can be run in the Rive runtime environment. Okay, so remember, we're going to go into our iOS app. So we're going to go into our main module. We're going to go to iOS app. Now, there are ways you can have the same artifact used by both platforms, but for the sake of this talk, I'm just going to copy to both. So we're going to go into the iOS app, and I just created a directory here, but actually, on iOS, it'll find it no matter where it is. Coffee Robot, okay? Save. Now we're going to export it to Android. We're going to go into Rive Talk. We're going to go into Compose app, remember, and then we're going to go into Source, Android main, and then we're going to go into the resource module, and I created a raw directory here, which does have to be raw, and then Coffee Robot. Okay, save. So we've done that. Now I'm going to go back into iOS. Here's our simulator in iOS. That was the default Hello World app. So we're going to overwrite that with super coolness. Okay, it's building. Now we're going to go to Android, and we're going to show the simulator. We're going to run this one. And now while they're booting up, I want to go back here and just zoom in real quick and just show you some of the fun things we did here. So our robot's marching along. You can see if you can't really see, it's too dark, but there's like a road kind of going this way. Also, we got some splashing coffee. We have blinking eyes. We have a donut waving around, and we have this antenna. So this is fun. I think it's really fun animating stuff. That was fun. All right, let's see if this all worked. Let's go to iOS. Boom. We have a running robot in iOS. Oh, where'd he go? There he or she is. There they are. And now we're going to go to Android. Boom. We have a running robot in Android. Thank you so much. I'm 2 minutes over. Allow me real quick to just say this. I want to thank a few people. I want to thank my friend Mike for drawing me the coffee robot image. He's the artist. I could never draw that. I want to thank my friend Christian for introducing me to Rive. I want to thank Philip Lackner and John O'Reilly. These guys provided most of the content which helped me understand the Swift UI stuff. So thank you to them. That's it, folks. This talk is available on GitHub. And are there any questions? Any questions? Oh, sorry, you want to see the GitHub repo again? Okay, again, thank you all for being here. Yeah, that's the Rive talk. Thanks, folks. Enjoy, and again, thanks for sticking around so late. Enjoy your trip home.